Part of the lab, I'm inspecting the running Docker containers to understand the full data pipeline and then measuring the latency between Postgres and ClickHouse using timestamps. So I'd already run it, but I'm going to go ahead and type it again. We first start with Docker PS. So as you can see, the command shows that all running containers in the pipeline. We can see services like Postgres, Kafka, Debezium, Kafka Connect, ClickHouse, and the custom producer, transformer, and consumer services. So each container basically represents a different stage of the streaming data pipeline. So the pipeline works as a change data capture system. Postgres is a source database. Debezium captures changes from its write-ahead log. Kafka transports the events, and then ClickHouse stores the process data for analytics. We're going to now move on to our timestamps, but before that, we're going to have to go ahead to work in ClickHouse. So we'll type in Docker exec. To ensure that we're making changes on here. I'm going to go ahead and run that. Now we can go ahead and run our query, but so I'll explain. The two timestamps that we have are received at and processed at. Received at represents the time when the order was originally inserted into Postgres, and it marks the event that was created in the source system. Then we have processed at, which represents the time in which the order was fully processed and written into ClickHouse after passing through Kafka and the transformer. So the difference between received at and processed at represents the end-to-end latency of the pipeline. So how long it takes to move for data to move from Postgres through the streaming system into ClickHouse. So when we run the query, we're basically calculating the average time difference between the two timestamps using the date diff function in milliseconds and seconds. So our result shows an average latency of several minutes, but this does not reflect real-time pipeline performance. I think instead it reflects the way in which the data set was generated, where timestamps are pre-created or historical rather than streaming in real time. So in a real CDC pipeline, we'd expect this latency to be in milliseconds or a few seconds. Thank you.